Hello to everyone. My name is Angel Manuel Guerrero and I come from the robotics group at the University of León. I have recorded this short video to explain our contribution to the CISIS 2020 conference that, as you can see in the title, is a brief literature review of detection techniques for advanced persistent threats. Before starting, I would like to thank the Spanish National Institute of Cybersecurity for their support to this research. We will start by defining the concept of Advanced Persistent Threat, APT. An APT is an attack directed to a specific entity and usually consists of a combination of processes and techniques such as port scanning, malware distribution, network lateral movements, privilege escalation, zero-day attacks, and social engineering. The detection of these types of attack is very important, not only for the affected entities, but also for the researchers working in security. A well-known example of APT that allows knowing its scope and impact on security is Stuxnet. Stuxnet is a worm that mainly attacks SCADA systems and allows for reprogramming PLCs. The existence of Stuxnet was announced in 2010 after the attack on the uranium enrichment system at Iran, which damaged approximately 1,000 centrifuges. After the incident, the problem of APTs began to become one of the major concerns in the field of security. The main problem lies in the difficulty in detecting and identifying an APT, since such identification cannot be achieved only by detecting malware or anomalous traffic. In addition, it is necessary to know certain features of the attack, such as the objective of the attack, the infrastructure of the attack, or, in the best scenario, the attacker himself. APTs also use unique attack signatures that make detection difficult, and the associated traffic use concealment mechanisms such as encryption or steganography. In addition, it is common that the infrastructure used to control the attack has not been used before in other attacks, which makes detection even more difficult. Another problem is that cybercriminals who carry out an APT do not expect a short-term benefit, and they can afford to keep a malware hidden so that the APT attack process develops over a long period of time. In recent years, a lot of researchers face the problem of APTs, focused both on the analysis of attacks already carried out and on the detection of new attacks. This work focuses the study only on the detection of anomalous traffic, with the aim of extrapolating these results for the detection of APT attacks that generate such anomalous traffic in some of its phases, such as port scanning in its data collection phase. Regarding the above context, we aim to answer the research question you can read in the slide. Our interest is born in the robotics group collaboration with INCIBE. From 2018, our research group has been collaborating with Supercomputación Castilla y León in the detection of APTs on Red de Ciencia y Tecnología de Castilla y León. To carry out our study, we follow the recommendations of Kitchenham as well as the Prisma guide. You can see references in the slide. The methodology is divided into 4 phases: a search planning, a search process, a sample selection, and a data extraction. Once it has been verified that a similar study has not been carried out, the search for the articles has been planned. Several sources of information were considered: Web of Science, IECube Digital Library, Scopus. Moreover, we include some articles recommended by other members of our research group. 2 search strings have been applied to each one of the previously indicated databases. The search strings have been constructed from the keywords extracted after applying the Peacock strategy to the research question posed above. Both search strings are shown in the slide. Then, one of the filters applied during the search is related to the publication date of the articles, because when working in a field that evolves so quickly, such as cybersecurity, we should focus only on recent articles. In this way, the search has only been performed for articles published between 2015 and 2019. On the other hand, only articles whose access is free have been selected. In order to select the samples, a filtering process was planned. First, duplicate articles are removed. Next, filtering was carried out based on the reading of the abstract of each of the remaining articles. To decide whether a particular article is marked as accepted or rejected, inclusion and exclusion criteria have been established. In this way, articles that meet at least one exclusion criteria or that do not meet any of the inclusion criteria are rejected. The inclusion and exclusion criteria are shown in the slide. Finally, in order to achieve the objective of analyzing approximately 10 articles, a questionnaire for evaluating the quality of each article has been developed. This questionnaire is fulfilled after the complete reading of the articles that had been selected in the previous phase. We have formulated all the questions so that they could have a yes or no answer, rating these answers with 1 or 0 points. So the maximum score that an article can reach is 6 points. A 4-point inclusion threshold has been established, so only articles with a score of 5 or 6 are selected. Finally, it is necessary to establish the method of extracting the data that are of interest to our investigations. Once the number of the articles has been reduced, a data extraction form has been applied. Data is extracted from the complete and detailed reading of each of the articles. The variables we are interested in are shown in the slide. Let's see the results. The searches performed on the databases mentioned above yield a total of 44 articles. 6 of these articles were eliminated because they were duplicated. Then, the criteria defined above for inclusion and exclusion were applied. After applying these criteria, the number of selected articles was reduced to 17. Finally, after the application of the questionnaire described above, 8 articles have been rejected, so the set of samples to be analyzed in the study includes 9 articles. Relating to the data extraction, we focus on 2 main elements when analyzing the selected articles: the datasets and the algorithms used. The articles analyzed cite 5 datasets, as you can see in the table, and regarding the algorithms, the most frequently used are decision tree, k-nearest neighbors, and naive Bayes, that are used on 33% of the articles. Their accuracies at different datasets and the tools used are shown in the table. As seen in the table, the most used tool is Weka. And regarding the conclusions, in this work, a systematic review has been carried out to know the tendencies when applying automatic learning about intrusion detection. The results show that the UNSWMB15 dataset offers good results when classifying network traffic. Therefore, this dataset can be useful when developing an intrusion detection system. After data extraction, it has been concluded that the algorithms that offer the best precision are the decision tree algorithm and the k-nearest neighbors algorithm. It is necessary to point out that the results presented in this work, despite showing high detection accuracies, do not solve the problem of detection of traffic-based APTs. The nature of APTs make it necessary to consider many types of attacks when trying to detect these types of threats, and so it is useful to know the tools and algorithms commonly used to detect those attacks individually. The results obtained during this investigation can be a starting point for new studies that try to develop systems to detect attacks of the APT type. This is it. Thank you for your attention.